Look up at the sky right now. If you're indoors, move to a window. Take a good look at what's above you. Most people see a vast, empty space, a dark ocean of nothing stretching out forever. Ever since you were young, you've been told the universe is endless, that it just keeps going without any boundary or final stop. That idea feels natural. It seems to make sense, but it's completely wrong. Not just a little off, but fundamentally and dangerously incorrect. Here's a fact that should keep you awake at night. If the universe truly stretched on forever and had always been there, the sky at night would not be dark at all. It would be blazing white, as bright as the surface of the sun. Every single spot in the sky would eventually lead to a star, but instead, it's dark. That darkness is a vital clue, like evidence left at a crime scene, telling us that the endless universe you believe in is a lie. So if space isn't infinite, does it have a boundary? If you traveled in a spaceship for long enough, would you smash into a wall? Would you fall off into nothing? No. The reality is far stranger than a simple wall. I came across something in the mathematics of shapes and connections that hints our reality is contained within a form you'd never guess if I just described it. Let me walk you through it. First, we need to break an old habit. Stop using the phrase, the universe, so loosely. It's sloppy, and in physics, being sloppy gives you the wrong answers. You need to grasp that there are actually two universes. There's the whole universe, everything that exists everywhere, and then there's the part we can see. This difference isn't just about words. It marks the boundaries of your confinement. Here's the situation we're stuck in. Light travels at a fixed top speed. It moves at 300,000 kilometers per second. That's fast, yes, but on the scale of space, it's as slow as a snail crossing a continent, because the universe has a starting point. Roughly 13.8 billion years ago, light from objects farther away than that hasn't had enough time to get to us yet. It's still traveling. Shut your eyes and picture this. You're standing in the middle of a dense, completely dark forest. You have a flashlight. Its beam only shines 10 feet in front of you. Does the forest stop at 10 feet? No. The forest could stretch on without end, but your world stops at the edge of that light. That's the observable universe. It's a bubble of knowledge centered on you at this moment. But hold on, your mind is tricking you about the size of that bubble. You might think, okay, the universe is 13.8 billion years old, so the boundary must be 13.8 billion light years away. Not correct, because space itself is stretching. While that light was making its way to you over billions of years, the space it moved through was expanding like pulled taffy. So the boundary isn't 13.8 billion light years off, it's actually about 46 billion light years away. That's the barrier, that's the limit. Everything inside that bubble is what we can observe. We know that part has limits. It holds a set amount of energy, a set number of atoms, around 10 to the 80, and a definite size. But here's the big question. What exists beyond the bubble? Is it just more forest? Does the forest stretch on forever? Or does the forest circle back on itself? If you walk straight past the edge of that light, do you keep walking endlessly, or do you eventually hit the back of your own head? Let's think about Pac-Man. Remember playing that game? When you moved Pac-Man to the right edge of the screen, he didn't hit a wall, he didn't crash, he didn't stop, he came out on the left side. If Pac-Man were a scientist, he'd claim his world is endless. He can move to the right forever. He never meets a barrier. He never stops moving. But is his world actually endless? No, his world is a limited box. It just follows a strange rule. The edges are linked together. This is what physicists call topology. It's the study of shapes, but not the basic kind from your school geometry class. This is about the shape of reality itself. Here's the part where most people stop listening, but don't, because this is crucial. You assume that for something to be limited, the universe needs a boundary, a drop-off you could fall from, a wall with a sign saying end. That's thinking in 2 dimensions within a 3-dimensional world. Consider the Earth. Start walking west. Just keep going. Will you ever fall off? Will you ever reach a wall that says end of Earth? No. You can walk west forever. Endless walking. But the Earth is not endless. It has a fixed surface area. It has a specific number of square miles. It's limited but has no edge. Einstein taught us that space isn't a fixed stage. It's a material, and materials can bend. If the universe holds enough mass, gravity warps space. If it warps it enough, space could curve back onto itself just like the surface of the Earth. So if you boarded a rocket and flew in a dead straight line, lasers locked, no turns, for billions and billions of years, you wouldn't meet a wall. You wouldn't enter empty void. You would eventually spot a very familiar planet. You would see Earth. You would return to where you started. You would collide with the back of your own ship. This is called a positively curved universe, a hypersphere. It suggests the universe could be a closed loop, a maze of reflections, a cage. But how can we tell if we're in a Pac-Man game or on an endless flat surface? We need to search for signs. Imagine a hallway that goes on forever. Now remove the hallway. Instead, picture yourself in a room completely covered with mirrors, floor, ceiling, walls. What do you see? You see countless copies of the room. You see countless copies of yourself. If you gaze deep into the reflection thousands of rooms away, you spot a tiny version of you. But is the room endless? No, it's just one room. The illusion of endlessness is created by light bouncing back and forth. This might sound like philosophy, but it's actually strict geometry. If the universe is limited but loops around like Pac-Man, then light could have had enough time to travel around it many times. That means when we look at a far-off galaxy, we might not be seeing a new galaxy. We might be seeing our own galaxy. Think about this. Light takes time to travel. So if you see your own galaxy after light has gone around the universe once, you aren't seeing it as it is now. You're seeing it as it was billions of years ago. You're looking at a ghost. You're looking at the Milky Way when it was young. Astronomers have actually hunted for this. They call it cosmic topology. They search for repeated patterns in the sky. Circles in the cosmic microwave background, the early picture of the universe, that match up perfectly on opposite sides of the sky. If we found matching circles, it would be the clear proof. It would confirm we live in a hall of mirrors. So far, we haven't found them. But that doesn't mean the universe is endless. It just means the room is larger than we thought. Maybe light hasn't had time to complete a full circle yet. Maybe the mirrors are too far away. But let's consider the opposite. What if the universe is endless? What if it goes on forever in all directions? That might sound reassuring, right? Wide open space, freedom, wrong. An endless universe is not freedom. It's a nightmare. If the universe truly goes on forever, then something horrifying happens to you, specifically to the atoms that make you up. Let me explain the math that shows you are not one of a kind. Let's play a game called the copy-paste universe. This is where your gut feeling fails. You might think endless just means very big, like a giant sandbox with limitless room. No, endless means everything that can happen does happen. Everything that is physically possible must happen not once, but an endless number of times. Think about a deck of cards. If I shuffle it, there are about 8 times 10 to the 67 possible orders. That's an amazingly huge number, but it's limited. Now imagine I shuffle the deck an endless number of times. Eventually I'll deal the exact same hand again. Eventually I'll deal every possible hand. Now stop thinking about cards. Think about the universe. The universe is just a large deck of cards. The cards are quantum particles. Every atom in your body, every electron, every quark is just a card in a certain order. Your brain state, your memories, your eye color, it's all just a pattern of particles. There are only so many ways to arrange particles in a given volume of space. Physicists have calculated this number. It's huge. It's 10 to the 10 to the 115. But here's the catch. If the universe is endless and space goes on forever, then nature has an endless number of chances to arrange particles. It's like rolling dice forever. Eventually, you'll roll snake eyes 1 billion times in a row. So if you travel far enough, about 10 to the 10 to the 29 meters away, you'll find a region of space where the particles are arranged exactly like they are here, exactly like Earth, exactly like you. That person will look like you, speak like you, remember your childhood, but maybe they made one different choice this morning. Maybe they wore a red shirt instead of a blue one. Keep going further. You'll find another you and another and another. In an endless universe, there are endless copies of you, endless Earths, endless histories. This is the monkey problem. If you give a monkey a typewriter and endless time, it will eventually type out Shakespeare. If you give the universe endless space, it will eventually type out you again and again. This destroys the idea of you being special. It makes you a common thing, a repeated pattern on wallpaper that never ends. Does that sound like reality to you, or does it sound like a mistake? Most physicists hate this idea. It feels wrong. It feels like a broken machine, and there's a reason they hate it. Because there's a strict limit built into the fabric of reality that suggests endlessness is impossible. A limit so tiny you can't even see it. You think space is smooth, like a slide. You can slide down it forever, right? You can zoom in forever. Wrong. Space is not smooth. It's made of tiny blocks. Zoom in on your hand. You see skin. Zoom in more cells, more DNA, more atoms, more protons, more quarks. Keep going. Eventually you hit a barrier, a basic terrifying barrier. It's called the Planck length. It's about 1.6 times 10 to the minus 35 meters. This is the smallest possible measurement of distance in our universe. Anything smaller than this, and physics as we know it completely falls apart. It stops making sense. Think of a video game. Look at Mario. If you zoom in on Mario's face, eventually you see square pixels. You cannot zoom in between the pixels. There is no half pixel. The game engine doesn't allow it. Our universe has a pixel size, the Planck length. So if space is made of separate chunks, then the universe cannot hold endless information in a limited volume. This is where the standard model runs into trouble. If space has the smallest possible unit, then there is a maximum amount of information you can fit into any area of space. This is called the Bekenstein bound. It says that a limited volume of space can only hold a limited amount of information or entropy. If you try to pack more information into a region than the Bekenstein bound allows, something terrible happens. You create a black hole. But if the universe were truly endless in every way, endless detail, endless precision, then every single point in space would contain endless information and the universe would instantly collapse into a black hole. But it hasn't. We're here. We aren't stretched into nothing. So the universe cannot have endless detail. It must be made of pixels. And if it's made of pixels, it suggests something deep about the nature of reality. It suggests the universe can be computed, like a simulation, like a program running on a machine with limited memory. It suggests that endlessness is just a simple math trick we use when we don't have the real answer. But if the universe isn't endless, what shape is it? The evidence is starting to hint at an answer, and it looks like a donut. Let's talk about a torus, or if you like, a donut. This is the strangest idea in modern cosmology, and it's not just a random thought. It's based on real measurements. The cosmic microwave background, or CMB, is the early picture of the universe. It's the leftover glow from the Big Bang. When we look at it, we expect to see a random mix of hot and cold spots, like static on a TV. And for the most part we do, but there is a pattern in the static that shouldn't be there. It's called the axis of evil. No joking. Physicists call it that because it challenges everything we understand about the cosmos. Imagine you're looking at a soccer ball. If you only see one hexagon, you can't tell the shape of the ball. But if you see enough hexagons, you notice they curve. They connect. The CMB has patterns. Specifically, the largest hot and cold spots line up in a way that suggests the universe has a specific closed shape. If the universe were endless and flat, these spots should be random. They shouldn't line up, but they do. And the shape that matches the data best is a 3 torus. This is a 4-dimensional donut. Think about the game Asteroids. Remember how if you fly off the top of the screen, you appear at the bottom. And if you fly off the right, you appear on the left. That is a 2 torus. It's a flat surface that wraps around itself like a tube. And then that tube wraps around itself like a donut. If our 3-dimensional universe is a 3 torus, it means space is limited but has no edge. You can travel in any direction, up, down, left, right, forward, back, and you will never meet a wall. You will eventually return to where you started. But here's the striking part. In a 3 torus universe, light can take different paths to reach you. Some paths are short, some are long, some loop around the donut hole, some go through the hole. This means you could look in one direction and see a galaxy as it was 1 billion years ago. Look in another direction and see the same galaxy as it was 5 billion years ago. You would see multiple versions of the same object at different ages. It would be a hall of mirrors, but twisted and warped. But if the universe is a donut, what is outside the donut? This is the part where your mind struggles. What is outside the donut? What is outside the universe? The answer isn't empty space. The answer is that the question doesn't make sense. Stop asking it. Let me explain why. Imagine you are a two-dimensional stick figure living on the surface of a giant balloon. You can move forward, backward, left, and right. You live in a two-dimensional world. Now, someone asks you, what is outside your world? What happens if you jump up? Up, you ask. What is up? You don't have a word for up. Your entire reality is flat. There is no outside the surface of the balloon. The surface is the universe. Now take a deep breath. You are a three-dimensional creature. You understand length, width, and height. But the universe might be a four-dimensional shape, just like the balloon is a three-dimensional shape. When we ask what is outside the universe, we are the stick figure asking, what is up? There is no outside. The universe contains all of space, all of time, all of the dimensions. It doesn't need to be inside anything else. Think of the surface of the Earth again. Is there an edge to the Earth where you fall off into space? No. Is there a center on the surface of the Earth? No. Every point is the same. Is the surface of the Earth endless? No. But it has no boundary. The universe is exactly like that. It is limited, but has no edge. If you travel in a straight line, you eventually come back to where you started. But you never leave the universe because there is no outside to leave into. Space is not a container. It is the stuff inside the container, and the container is the stuff itself. But there is one problem with this idea. We know the universe is expanding. The balloon is getting bigger. So what is it expanding into? Let's blow up a balloon. Draw some dots on it. These are galaxies. As you blow into the balloon, the dots move away from each other. Are they moving? No. The space between them is stretching. This is exactly what is happening to our universe. It is expanding faster than the speed of light. But what is it expanding into? Nothing. It is creating new space as it expands. Think of it like knitting a scarf. You are adding new loops of yarn. The scarf gets longer, but it isn't moving into a pre-existing space. It is creating its own space. This is inflation theory, and it solves a huge problem. If the universe started as a tiny dense point, a singularity, and then exploded outward, why is the universe so smooth? Why is the temperature the same everywhere? If I pour hot coffee into a cold room, it takes time for the heat to spread. But the universe is uniform. Everywhere we look, the temperature is 2.7 Kelvin. This suggests that just for a tiny fraction of a second after the Big Bang, the universe expanded faster than light, much faster. It stretched out any wrinkles. It smoothed everything. And here is the frightening part. Inflation might not have stopped everywhere. Maybe our universe is just a bubble where inflation stopped. A calm patch in a chaotic boiling ocean of eternal inflation. Outside our bubble, space is still expanding exponentially forever, creating new bubbles, new universes, endless universes. But our universe, the one we can see, the one we can measure, it is limited. It is a bubble. It has a specific size, a specific age, a specific end. And the reason we think it is endless is because we can only see a tiny piece of the curve. Like an ant on a basketball, the ant thinks the world is flat. But if he walks far enough, he realizes he is on a sphere. We are ants on a cosmic basketball. But there is one final mind-bending possibility, one that makes the entire concept of size meaningless. What if the three-dimensional universe is an illusion? What if we are actually two-dimensional? Let's talk about a hologram. You've seen them on credit cards. It's a flat two-dimensional image, but if you turn it, it looks three-dimensional. It has depth, but the depth is an illusion. The information is all stored on a two-dimensional surface. Now look at the universe around you. It looks three-dimensional. You can move up, down, left, right, forward, back. But what if the universe is a hologram? This is the holographic principle, and it is not science fiction. It comes from studying black holes. When matter falls into a black hole, it disappears. But the information about that matter, its quantum state, cannot be destroyed. That is a fundamental rule of physics. So where does it go? It gets smeared on the surface of the black hole like stickers on a balloon. The information is stored on the two-dimensional surface area of the event horizon, not in the three-dimensional volume inside. Think about a can of soup. The label on the outside tells you exactly what is inside. You don't need to open the can to know it contains tomato soup. The two-dimensional surface describes the three-dimensional volume perfectly. Now apply this to the entire universe. The holographic principle suggests that all the information in our three-dimensional universe, every star, every galaxy, every thought in your brain, might actually be encoded on a distant two-dimensional surface, a cosmic horizon. If this is true, then the three-dimensional space we think we live in is just a projection, a shadow. And if it is a projection, then the endlessness of space is just a math trick. The universe isn't endless. It has a set amount of information, a set resolution, a set number of bits. It is limited. It is bounded by a horizon. It is a cosmic hard drive, and hard drives get full, which leads to the final unsettling conclusion. So where does this leave us? Stuck in a box, living on a donut, a smudge on a hologram. It sounds confining. It sounds like a jail. But let me turn that around for you. If the universe were endless, truly physically infinite, then you would mean nothing. Remember the monkey? In an endless universe, there are endless copies of you, endless Earths, endless mothers, endless first kisses. You become a common thing, a cheap copy, a rounding error in a spreadsheet that never ends. But if the universe is limited, if the deck of cards is only shuffled once, then you are rare. You are not a copy. You are a special edition, a unique, one-of-a-kind arrangement of atoms in a limited amount of space and time. The darkness of the night sky isn't an empty void. It is a soft curtain around a treasure box. It tells us that the light is special because it is rare. We are delicate, and we are stuck in this beautiful, limited bubble together. So the next time you look up and see the dark, don't fear the emptiness. Be thankful for the boundary, because without limits, nothing has form. Without an end, there is no story. And I want to hear what you think. Does a limited universe bring you comfort, or does it make you feel confined? Tell me in the comments. And if you want to challenge your mind even more, click this video next. Because if space has limits, what about time?